Okay, so now we're on to part 2 of lesson 71. Make sure you have your heading on. Name, number, date. First and last in cursive. Make sure that you're writing the date you are working on these notes and not necessarily the date I'm writing. Our subject is math. Now on the other side of the notes we had a problem with having it too light. The copying did not show well. The problem on this side is that it ended up too dark. So originally it should have looked like this and this for these two, but it's hard to see. So just do the best you can to try to trace where those lines you think they would be for the three trapezoids that are together, and just kind of figure out where that circle would go. It's not perfect, that's okay. Here you can see the lines fairly well for the rhombi, but to see that there's actually a circle that's on top of it might be hard to see. But they were supposed to copy out like this. Sorry about that. Alright, so let's look at the first one. So to figure out how angles are in other shapes, we still use the circle, because a circle we know is 360. That's what we start with. We accept that as true. Okay, we're going to use the circle to find the measure of one of the interior angles of a hexagon. So if we fit 3 hexagons together, if you remember your pattern blocks, they're the yellow ones, they fit together perfectly, and if we set a circle on top of it, it cuts that circle into thirds, if this is in the very center of it. So just like on the other side, if I take 360 degrees and divide it into 3 equal pieces, that will give me my answer. Now you could look on the other side because we did thirds already, but just to show you different ways that we could set up our division, 360 divided by 3, 100 times 3 is 300. Numbers the same, zeros a game, or on top, no need to stop. Numbers the same, zeros a game. 20 times 3 is 60. Numbers the same, zeros a game. Add them together and we get 120. If we check, divisor times quotient plus remainder, but our remainder is 0. 3 groups of 0 is 0. 3 groups of 2 tens is 6 tens. 3 groups of 100 is 300. So each one of these is 120 degrees. 120, 120, 120. So that's how we can figure out angles in another shape, is by comparing it to a circle. So one of the interior angles of a hexagon is 120 degrees. So here we have 3 trapezoids. So if we were looking at pattern blocks, they would be the red ones, I believe. And again, if you set that circle on top where you put the same angles together, it cuts it into thirds. So 360 degrees divided by 3, well, we've already done the work once, is 120 degrees. So this part of the trapezoid on each of these trapezoids is 120 degrees. So one of the obtuse, because the other angles are cute, it's not going to be the same. One of the obtuse interior angles of the trapezoid is 120 degrees. So comparing it to a circle is how we find those other angles, but they do need to be at that center of the circle. Okay, here we're looking at a rhombus. 3 together, we call them rhombi. Set that circle on top with the 3 obtuse angles together, because remember obtuse is greater than 90 degrees. We put those 3 large angles together, so we're dividing it into thirds again. Do you see a pattern here? If I divide it into 3, we already did the work, we know is 120 degrees. So each of these obtuse angles is 120 degrees. This would be the blue rhombus shape in the pattern blocks. Now we're only talking about the obtuse angle because the acute angle would be less than 90 degrees. So one of the obtuse interior angles of the rhombus is 120 degrees. That's of this blue one. Okay, we have these little, and in the pattern blocks they'd be the green ones. The little green triangles, these are what are called equilateral because all the sides are the same length, and actually all the angles are exactly the same measure. If we fit these little triangles together, for one thing it looks like a hexagon. These would fit perfectly on one of those yellow hexagon. I set the circle on top where they join together is that center point. So I'm actually taking the circle and I'm going to divide it into 1, 2, 3, 4, 5, 6 pieces. So 360 divided into 6 equal pieces. 50 times 6 is, placeholder moves it over place, 5 times 3 is, so I'm sorry, 6 is 30. So we get 300. Numbers the same, zeros a game, more on top, no need to stop. Numbers the same, zeros a game. 10 times 6 is 60. Numbers the same, zeros a game. Add these together, 50 plus 10 is 60. We check. Divisor times quotient, 6 groups of 0, 0, 6 groups of 6 tens is 36 tens. So each of these is 60 degrees, and that is actually true in all equilateral triangles. They're all 60-degree angles inside. So they're also acute and equal angular. So one of the interior angles of the triangle is 60 degrees. Okay. So this one's hard to see, but these are the tan rhombuses. It should have looked like this, but we're not going to draw it. Kind of looks like a sunburst. So this is what we're looking at with that circle on top of it. So if we look at my picture, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 that we're looking at. So we're going to divide it into 12 equal groups. We're not going to worry about drawing it. So 360 degrees divided into 12 equal groups. Those are the acute ones of these 10 rhombi. Let's see. 360 divided by into groups of 12 and multiply by 10. Everything moves over a place, so I get 120. Numbers the same, zeros a game, more on top, no need to stop, more on top, no need to stop. I'll do another group of 10 because it just moves it over a place. Numbers the same, zeros a game, more on top, no need to stop, more on top, no need to stop. And there we go. I know how to get 120. Numbers the same, zeros a game. Add them together, 10, 20, 30. And if we check, divisor times quotient, the placeholder moves it over place. 30 groups of 2 is 60. 30 groups of 10 is 300. So we get 30 degrees each. I'm not going to write them in because they're so small. So one of the acute interior angles of the rhombus is 30 degrees. And last one, the orange squares from the pattern blocks. So this time it's cut into 4 equal pieces with that center there, the circle. 360 divided by 4. Let's see, 4 times 50. Placeholder moves it over place. 4 times 5 is 20. Numbers the same, zeros a game, more on top, no need to stop, more on top, no need to stop. Let's see, I know that 4 times 4 is 16, so 4 times 40 is 160 because it moves it over a place. Numbers the same, zeros a game. Add these together, 50 plus 40 is 90. Remember how we refer to them as those square angles? Because they actually are what make a corner of a square. 90 degrees. Now we check. Divisor times quotient plus remainder. 4 times 0 is 0. 4 groups of 9 tenths is 36 tenths. So one of the interior angles of the square is 90 degrees. All right, so now we're going to practice some more with angles as fractions of a circle. And that's how we also find the angles for other shapes, like squares, trapezoids, hexagons, rhombi, any of those. All right, thank you for joining me.